I can't believe it. I simply cannot believe it. How can there be so many sites on the internet claiming that they can teach you how to convert a binary number to a base 10 number and a base 10 number to a binary number in a very simple and easy way, and yet none of them can tell you how to do it in your head? It all requires pencil and paper. No, no, no. This is very, very simple. And I'm going to teach you how to do it in your head. How much in your head? Well, take the number 2016. This is 2017, but the new number 2016 is it's an interesting number. I'll teach you how to convert the base 10 number 2016 to a binary number in your head. All right, let's get started. We're going to start with the number 37. When you write a binary number, you start on the right side and proceed to the left, just the opposite of writing a number normally. You start at the right and you go to the left. You use the numbers 1 and 0 to designate a number which is odd, 1, or even, 0. And I show the two numbers here, 1 and 0. The number 37 is obviously odd, so we'll enter a 1 in the rightmost square. As we proceed to the left, we're going to divide by 2 with each square. So in the next square we divide 37 and we get 18.5. We always round, so that will be considered 18. 18 is an even number, so we enter the even number 0. Continuing, we divide again by 2, which yields a 9. A 9 is an odd number, so we enter a 1. Dividing by 2, we have 4.5. Changing that to a 4, we have an even number, so we add a 0. Dividing again by 2, we have a 2, which again is a 0. Dividing again by 2, we have, of course, a 1. We must always have a 1 in this square, for it is the first number of the first digit of the binary number, which must be a 1. Okay, now we need to go the other way. We need to convert a binary number to a base 10. So we know what we're dealing with here. We should end up with 37. Let's see if we do. We start with the 1 on the leftmost box, and we double that, and we get 2. There's a 0 in that box, so nothing more to be done. Double it again, we get 4. Nothing more to be done. There's a 0 there. Double it again, we get 8. Uh-oh, there's a 1 there, so we have to add a 1, and we have a 9. Double it again, we get 18. There's a 0 there, nothing more to do. Double it again, we get 36, and again there's a 1, so we add a 1, that's 37. We've got our answer. Before I let you go, I've got to warn you about another strange animal that's running around out there. You won't run into this very often, but there are such things as binary decimal numbers. In other words, you'll see a binary number with a decimal point and then more digits to the right. Strange but true. All right, here's one I'm throwing out as an example. And I've got 5 digits on the left and 5 digits on the right, which could be confusing, but we only want to consider those digits on the right. We want to get rid of that decimal point, so we must multiply. By what do we multiply? Well, it's 32. How do we get that? 5 digits. 2, 4, 8, 16, 32. So we'll consider it multiplied and just consider the same numbers but without the decimal point. Now we evaluate this by the method which I've shown you. You can do this in your head, and you get 677. You then divide that by 32, and you get 21.15625. Now this is the base 10 decimal, which is equivalent to the binary decimal there at the beginning. Hardly ever use that, if ever, but I just thought I'd pass it on. Okay, you've learned now how to convert binary to base 10 and base 10 to binary in your head. You don't need, well, you need to write down your answer, I suppose, but that's the only time you'll need pencil and paper. What can you do with this? Well, you're not going to design computers with this. There are just very few people that do that sort of thing. So why do you need to know? Binary numbers are taught in school, so it's what I've taught you here is handy there. But it also has some other uses. Logic engineers, as I indicated, or maybe I didn't. Now, logic engineers use binary numbers all the time, and they need to have this handy way of converting decimal 10, base 10 numbers to binary in their head. They can't fool around with those other long methods. So they, of course, need it. You can wow your friends by being able to do something they can't do. That's a small plus. You can show it to your teacher if you're in school, and don't be surprised if he or she gets very angry. It is their purpose to dumb you down, and when you hand along information like this, which makes them look like a bunch of idiots, they don't like that, and they can get very angry. You can show this to your math friends where you work, and they too will be impressed by your abilities. All right, that's about it. I'll let you go. Thanks for listening.